Hello everyone, welcome back. So in this video we are going to start numerical integration. Numerical integration. Okay, so if you are first time to my channel, please consider subscribing. So as I've told you, numerical integration consists of three concepts. One is trapezoidal rule, second is Simpson's 1/3 rule, and third is Simpson's 3/8 rule. Okay, so we'll discuss one by one what is the formula in each and every concept. Okay, so first is trapezoidal rule. Okay, so first is trapezoidal rule. So in trapezoidal rule, as I've told you, this is integration. They will give you something like this. So y is equal to a to b. So they'll give they will give to find the value of this integration a to b f of x dx. Okay, and they may give you the step size also. Okay, in the problem they may give you step size h. We'll represent it with h. Okay, so if they are given like this, so what you have to do is, first of all we have to consider y is equal to f of x. So okay, so we have to consider y is equal to f of x. So starting from a to b, we have to take of this step size, and then we have to find the corresponding values of y. Okay, so I'll take an example in order to explain it clearly. Okay, so this I am considering it as x0 to xn. Okay, f of x dx. If you are given with like this, you can take a and b, or I am taking x0 to xn. Okay, suppose take an example 1 to 3, 1 by x dx. So find the value of this numerical integration with a step size of 1, if they are given with step size of 1. So what is the rule, or what is the thing which you have to do in numerical integration? I am telling you the generalized concept. Only formulae changes in all the three, but the concept is same and the methodology is also same for all the three methods. Okay, so if you are given like this 1 to 3, 1 by x dx, h is equal to 1, that is size is equal to 1. So what you have to take here is, we have to first consider y is equal to f of x, which is also equal to 1 by x. Okay, so the limits are now from 1 to 3 with a step size of 1. So 1, the lower limit first you have to write here, so that is value of x. Okay, so that is the value of x, and then with the step size you have to add. That means 1 is added with 1, so this 1 is added with 1, you will get 2, and 2 again is added with 1, you will get 3. So that will be the maximum limit. So these are the values of x possible for this step size. Okay, so for the given value of step size, these are the values possible. So now for these values you have to find y is equal to f of x, which is equal to 1 by x. Okay, so 1 by, what is the x value in this case? So it is 1 by 1, which is equal to 1. So here 1 by 2, which is equal to 0.5, and similarly in this case this is 1 by 3, which is equal to 0.33. Okay, so this becomes y0, this becomes y1, and this becomes y2, and so on. Okay, so this is valid for step size 1. So if I take a step size is equal to 0.5, if I take a step size, or given in the problem such that the step size is 0.5, then what you have to do is, you have to take the values of x, next the lower limit. Okay, so 1, and step size is 0.5, so we have to we have to take the values of x with increment values of 0.5 and up to 3. So 1, the next is 1.5, next is 2, next is 2.5, next is 3. Okay, so now we'll take y is equal to f of x. So this is 1 by 1, 1 by 1.5, this is 1 by 2, 1 by 2.5, and this is 1 by 3. So this becomes y0, this is y1, y2, y3, y4. Okay, similarly if the step size is 0.25, if the step size is 0.25, we'll get correspondingly 9 values. Okay, so 1, what are the values you'll get? So it will be 1, 1.25, 1.5, 1.75, 2. Next 2.25, 2.5, 2.75 and 3. Okay, so totally you will get 9 values totally. Okay, so if the step size is 0.25, so according to the given step size you will get the values of, you have to take the values of x, and based on the values of x you will get the values for y, that is y0 to y9 or y4 or y2, like this. Okay, so it all depends on the step size. If step size is more, number of values decreases. So here step size is more, so only 3 values for y we have got. So here step size is less compared to this, so there will be more number of y values. Okay, so if step size is still decreased, that is if you take 0.25, we'll get more values, that is 9 values. Okay, so this continues and so on. Okay, so after getting these values of y0, y1, y2, y3 and y4, we just have to substitute in the formula for all the 3 methods, that is for trapezoidal rule, for Simpson's 1/3 rule, and for Simpson's 3/8 rule. Okay, so this is the general method which you have to follow first, and then substitute in the corresponding formula for the asked method. Okay, so if the question asked is Simpson's 1/3 rule, use the corresponding formula. If the question asked is from trapezoidal rule, so use the corresponding formula. Okay, so this is the only difference, formula is the only difference between the 3 methods. Okay, so I am writing the formula now for trapezoidal rule. Integral x0 to xn f of x dx. So x0 to xn, like this they will give you. So this is 1 to 3, 1 by x dx. So this formula is given by h by 2 into sum of first and last ordinates, sum of first and last ordinates plus 2 into sum of remaining ordinates. Okay, so this is the formula. So is equal to, so in writing, so y0 plus yn, because if x0 is the initial value, its corresponding value is y0. If xn is the final value, its corresponding final value is yn we have taken, plus 2 into the remaining values, y1 plus y2 plus y3 and so on, plus yn minus 1. Okay, so these are the values which you have to substitute, and this is the formula in order to get this value. Okay, so you just have to substitute in this value. So after finding y0, we'll have the value of h, step size we are already having, so this h value is already present, and y0, yn, y0, y1, y2, so on up to yn is found out like this. Okay, is found out like this. We just have to substitute in this. So if you use this formula and apply it to this problem, what will be the value here? H is 0.5, so 0.5 by 2 into y0 plus yn, so y0 plus y4. So y0 value is 1, y4 value is 1 by 3 here. Okay, so 1 by 3, this value, so 1 by 3 and plus 2 into the remaining values, 1 by 1.5 plus 1 by 2 plus 1 by 2.5. That's all. Just find the value, you'll get the value for this integral. Okay, so this is how we can solve for trapezoidal rule, and this is the formula which you have to remember. Okay, so next we'll write the formula for Simpson's 1/3 rule. Okay, Simpson's 1/3 rule. So in Simpson's 1/3 rule, the formula is like this: x0 to xn f of x dx, same as we have taken for trapezoidal rule. So the formula is given like this: h by 3 h by 3 into sum of first and last ordinates, sum of first and last ordinates, plus 4 into sum of odd ordinates, 4 into sum of odd ordinates, plus 2 into sum of remaining even ordinates, that's all. Okay, so this is the formula. So generally writing h by 3 into y0 plus yn, so sum of first and last ordinates, plus 4 into sum of odd ordinates y1, y3, y5, y7 and so on. Okay, so plus 2 into even ordinates, that is y2 plus y4 plus y6 plus so on. Okay, so this is the formula for Simpson's 1/3 rule. Okay, similarly the formula for Simpson's 3/8 rule, Simpson's 3/8 rule is, so integral x0 to xn f of x dx is equal to 3h by 8, 3h by 8 into sum of first and last ordinates, sum of first and last ordinates, plus 2 into ordinates of multiples of 3. Okay, sum of the multiples of 3, that is y3, y6, y9 and so on, plus 3 into sum of remaining ordinates, sum of remaining ordinates, that is other than the multiples of 3. Okay, so this is sum of, I forgot to write sum of this. Okay, so generally writing 3h by 8 into y0 plus yn, sum of first and last ordinates, plus 2 into multiples of 3, that is y3, y6, y9 plus so on. Okay, plus 3 into remaining y1 plus y2, y3 is already here, so y3 is not included here, y4 plus y5, again y6 is here, so the remaining y7 plus y8 and y9 is there and so on. Okay, so this is the formula for Simpson's 1/3 rule and Simpson's 3/8 rule. Okay, so next we'll see some of the important points. Okay, some of the important points regarding the 3 types of numerical integration methods. So sometimes they may ask you directly one of these points. Okay, so theoretical points only. So I have told you already the formulae and the method how to solve the 3 methods. Okay, so that you can learn if problems are asked, and these are important points which you have to remember for theoretical questions. So sometimes directly theoretical questions in the form of match the following are being asked in numerical methods. Okay, so you can refer the previous question papers, you'll see that, right? So the first thing or first point here is error. So first thing is error. So error in trapezoidal rule, so the error in trapezoidal rule is of the order of h square. Okay, so order of O, here O represents order of. Okay, so we'll call it as order of h square. Similarly in Simpson's 1/3 rule, Simpson's 1/3 rule, it is order of h to the power of 4, and in Simpson's 3 by 8 rule, it is minus 3h to the power of 5 by 80 of order 4. So fourth order differentiation. So this is what you have to remember. So error in trapezoidal rule, order of h square. So these two are asked very frequently. Okay, so since they are straight away formulas. Okay, so the second point is order of fitting polynomial. Order of fitting polynomial. Okay, so order of fitting polynomial, trapezoidal rule is first order. Okay, and Simpson's 1/3 rule is second order, and Simpson's 3 by 8 rule is third order. So there is a lot of theory behind this, so that is not required for us. So just remember the order of fitting polynomial. So trapezoidal first order, Simpson's 1/3 rule second order, and Simpson's 3 by 8 rule, it is third order. Okay, so the next point is third point. So in trapezoidal rule, straight lines are used to model the curve. That means to draw the given function f of x, we will use straight lines. So in Simpson's 1/3 rule, we will use parabolas. Are used to model the curve. So these are very important, straight lines here and parabolas in the case of Simpson's 1/3 rule. Okay, so just remember this, it is enough. Next, fourth very important point here is in Simpson's 1/3 rule. In Simpson's 1/3 rule, the number of subintervals, that is the range of values from y0 to yn, that is how many values you are going to take here. These are called as subintervals. So the number of subintervals must be even. So the number of subintervals you have to take must be an even number. Okay, in Simpson's, this is asked many times in the previous exam. So Simpson's 3 by 8 rule, the number of subintervals, so the number of subintervals must be a multiple of 3. Okay, so this is very important point. So these two are very important points. Okay, fourth and fifth points are very important. So y0 to yn, this number of subintervals must be an even number, and in Simpson's 3 by 8 rule, it must be a multiple of 3. So you can remember these 2 points like this. So the order of fitting polynomial is third order, and similarly the number of subintervals must be multiple of 3. So Simpson's 1/3 rule, order of fitting polynomial is second order, which is an even number, and the number of subintervals required here must be also even. Okay, so these are the very important points which you have to remember for all the 3 types of numerical integration. So with this you can solve any problem given in the previous question papers or anywhere. Okay, in the next class we'll see the solution of algebraic and transcendental equations. Okay.